Hi everyone, thank you very much for tuning on to this channel. Before I start with my work for today, I would like to remind you that should you like this video, please don't hesitate to click on a red button or subscribe, or click on a notification, add a comment, or give my videos thumbs up. And I'll appreciate if you can watch my videos till the end because I don't want you to miss any single word from my mouth. Right. So today's topic is based on how to draw up shear force diagram of a simply supported beam with support shifted from ends 1 meter from ends of the beam. Right, without any waste of time, let us start with our work for today. Right, good people, here is your beam. This beam, I'm not going to recalculate the directions again because on my previous video, that calculations have been performed. So all I'm going to do now is just to take those directions from my previous uh, presentation. Right. Now, the magnitude of L that was calculated on my previous video was 95.95 newtons, and that of R was 104.047 newtons. Right. Now that I've written those magnitude and they are correctly labeled, I'll just name this R, okay, T S P, right? It's just to name those points. You'll see the importance of that point when you draw up shear force diagram, right? And people, before we carry on the shear force diagram, I would like us to apply Newton's third law, whereby we are confirming that our forces are correct. So the law of the Newton's third law states that upward forces mass equals to downward forces, right? For upward forces, you have 95.95 plus 104.047 equals to 65 plus 50 plus 85. So when you add both sides, you must get 200 newtons and 200 newtons. So we are good to go. By doing this, we are good to go. So good people, let us now start with the real work of the shear force diagram. We must first understand what is this shear force, what it consists of. Shear force diagram is derived from the forces here. Is basically shear force diagram is basically the impact that these forces, external forces, that is 65, 50, 85, 104, 95, the impact that it does on a beam here. So let me illustrate by drawing these two boxes here. We have got this box over here, and then you've got this box over there, and then they are meshing. I'll just write an arrow there, an arrow there. So these forces together, these boxes together, when you exert force or when the force is applied, the second picture will look like this. The second drawing will look like this, good people. Will look just like this. Because now after force is being applied, there will be shearing that have taken place here. They will be meshing against one another. Right. So this is basically what is happening on a beam here, good people. So I hope you understand this part. Right. Let us first start with our shear force diagram. And before we start with our shear force diagram, you cannot just draw. You must have scale. So for you to come up with a suitable scale, you must first study the forces here, the magnitude that we have. You can see the minimum force that we have here is 50 newtons, and the maximum one is 104.047. So your scale can be 1 centimeter equals to 50 newtons, right? So we are sure about our stuff now. Let us now prepare our Cartesian plane, our plane where we're going to show our diagram. So we're going to use this ruler to draw up everything. I'll just have my ruler like this. And then because I must do construction line first, I'll just use a different color. So let me just do this, draw the straight line here, draw the straight line there, and then I can tilt this vertically to mark my points. I just want to make sure that my diagram is going to be correct. Right, so I'll just first draw this line here, this line there, starting there, and then draw the second one. These are just markings. So let us just have this. Remember, these are just construction lines, so that our diagram can be accurate, can be neat, can be clear, can be readable, right? So it's always good to have your ruler straight vertically up, right? I hope you're following, good people. And should you have any comment, please, you must start commenting as you watch this video, right? And then I can just have this one here. I'll tell you why I must write this one just now, right? So I'll just tell you now. Right, now that we have our lines, I'll just change my pen here also. I'll make it red. I'll just make it red here so that at least everything will be clear. Right, now I said our shear force diagram starts from 0. So I'll just write 0 here, 0, and we'll end at 0. Right, so with our scale, I'll just draw our scale here, and then I'll write 50, 50, and 100, and then you've got minus 50, and then minus 100. Right, and this is our shear force diagram. And all these forces will be in newtons, right? So when you start, you must remember that forces that are negative, downward, we regard them negative, and upward ones, we regard them positive. Now, let us start. And people, when you press your calculator, make sure that you don't delete or do whatever till you get to the end. So you simply say negative 65. There's a force that is going down here, negative 65. Let us just have that one, negative 65. Negative 65. We start here, negative 65. Negative 65, it will be somewhere there, right? Let me just put my ruler aside and then write 65 here. We have 65 newtons, right? Then between this T and L, there isn't any force, good people. There isn't any force. Let us carry on. There isn't any force. Let us just speed up here the process. There isn't any force. You simply draw a straight line from this point to that point, from T to L. All right. And then when you get to L, we have got the magnitude of 95.95. So you simply say negative 65 is negative because it's below the line. Negative 65 plus 95.95 plus 95.95. So your answer to that should be 30.95, positive one. So if it's positive, it must be above the line. And we have our scale, with people. Make sure that you position your ruler correctly. And then we have got this starting from here, starting from there till somewhere there, right? Till somewhere there. So, and then you must write the magnitude also, which is 30.95 newtons, right? So between L and S, there isn't any force. There isn't any force that we can that has an impact on a beam. So just have to draw our straight line, our straight line, our straight line from this point to that, from L to S, from L to S, right? So when you get to S, there's a magnitude of 50. There's a magnitude of 50. So you simply say 30.95 minus 50, minus 50, minus 50, and that must give you negative 19.05, negative 19.05, 19.05, 19.05. So let us just jot it down. We have negative 19.05 newtons, right? So we can move on now. So you can see between S and R, there isn't any force. So we are just going to draw up the straight line from this point to R, from S to R. We simply have to draw the straight line from S to R. That's it. Then when you get to R, there is a force of 104.047. So you simply say negative 19.05 plus 104.07. That must give you what? That must give you 84.999. You can simply say that is 85, good people. 85 point that. Let me just have this. Right. So 85, it will be somewhere there. Right. Sharp. So now that we've got that value, you can as well write it as 85. So we have 85 here, 85 newtons. So between R and P, there isn't any force. There isn't any force that we can add or subtract there. There isn't any force that we can add or subtract. So we can simply draw up our straight line from point R till P. So when you get to P, there's a force of 85. Remember now it's negative and we have positive 85. I hope you're still, your calculator is still showing negative, positive 85, because you're just going to subtract now 85 from 85, and that must give you 0. That must give you 0, good people. Let us just have this. That must give you 0, good people. So that's that. That is basically your shear force diagram, good people. This was supposed to be our first line, good people. So, but anyway, as long as you understand how to draw up shear force diagram, that is the aim. That is my aim. So this was supposed to have been a first line that I've drawn. Good people. Thank you very much. So for being with me, let me just put this rule aside. So the top part here we regard as positive, and the bottom one negative and negative. So good people, that is basically a shear force diagram, the impact of these forces on your beam graphically. So if you are asked to draw up shear force diagram, this is exactly what is expected from you as a learner. Thank you very much for watching this till the end, and don't forget to subscribe. Thank you very much. Hope to see you on my next video.